First of all, I would like to thank the Things Conference to organize such a great event. It's really good to be here. So, as said, my name is Anicet Giaimo. I am Product Marketing Manager, and I am responsible for ST sub-gigahertz microcontrollers. So, many IoT applications for smart industries, smart agriculture, and smart cities require for low power and long-range connectivity network that we call LP1. But today, these markets are quite fragmented, with many radio protocols, many modulations, and different frequency regulations. So, to simplify the approach for our customers, we have created a system on chip called the STM32WL. And this product brings a flexible solution that can support multiple protocols and that can be deployed worldwide. So, in the next 20 minutes, I'm going to explain you how this product, this STM32WL, and its ecosystem can help you to streamline your application and to help you to design your wireless design. So, what is this STM32WL? This is actually the integration of a low-power microcontroller plus a multimodulation radio supporting LoRa modulation, for instance, and a Cortex-M0 Plus core in order to provide more security. And all of this has been integrated in a single die product that we call STM32WL, with WL standing for wireless long range. So, what does that mean for your application? So, on top of the flexibility it provides, the low power capability, the low power performance can help to extend the battery life of your application, making them more sustainable, for instance. And then the long-range capability of the radio can help to reduce the number of gateways in your infrastructure, reducing costs as well. And on top of that, there is the integration level, because having such microcontroller plus the RF integrated in a single device helps to reduce the size of the end device, increasing the level of integration. So, as you may know, we launched this product 3 years ago. And since then, we developed a whole ecosystem around it. And we did so with 3 key drivers in mind: integration, flexibility, and simplicity. So, let's start with the integration side. So on the integration side, as I said before, we are integrating the microcontroller plus the radio. But on top of that, in 2020, we have released a dual-core version of the product that brings to our customers more performance, thanks to the 2 cores, as well as more security, because it allows to have the application and the wireless stack and an hardware isolation in between. Then we have in our ecosystem great flexibility. And in order to provide to our customers and our partners a way to develop additional protocols, we have launched in 2021 a new cut of this STM32WL that supports long packets. And this, for instance, allowed our partner StackForce to support multiple stacks running on the same application using the same product, the STM32WL. In November this year, we are going to update our firmware package to support the LR-FHSS modulation. And this can help to support high-density network, for instance, and also to enable satellite connectivity. Then, last but not least here is about simplicity. In order, for instance, to simplify the PCB manufacturing of our customers, we are proposing the STM32WL in a QFN48 package. And this package, for instance, can allow to use and to lay out on a 2-layer PCB in order to reduce the cost of the PCB. Later, I will show you how to get access to the materials in order to start such kind of design. Then, our boards that can be used for fast prototyping are already certified, and that in order to guarantee the compliance with the LoRaWAN standard. So that's for the simplicity. But actually, we didn't stop here, because today, I'm pleased to introduce you our brand new reference designs and our IPDs, which will no doubt make a difference in your design journey. So we say that RF is complex, RF is time-consuming. Well, not anymore, because right now, with our reference designs, you have access to a set of schematics, to layouts, bill of materials, and firmware, so that you can reuse it to start your own LoRaWAN application, and you can save this way a lot of time in the development, in the design of the wireless and the RF. So that includes, if you can see, the supply circuit, the RF matching circuit, RF filtering circuit, and a list of the passive components that has to be used in the application. Here, we are not providing only one reference design, but it's actually a set of reference designs. And each of them has been fine-tuned to match with your country regulations. So from the low band to the high band, from the low power to the high power. So then you can get the best performance according to your configuration. You also can find reference design for the BGA, the small form factor package of the WL, or the QFN package of the WL in order to make an easy to layout solution. Reference designs are not only a way to design faster, it's also a way to get access to innovative solutions in order to reduce the cost of your total solution. By, for instance, having access to this material here that provide a two-layer PCB design. And this, here again, has been fine-tuned for each country regulations. Then, another solution also to reduce the total cost of the solution is to save the cost of the RX and the TX switch. And here again, we are proposing this solution called direct tie, that actually tie together the RX signals and the TX signal together in order to avoid the use of an RX and TX switch. So as you can see, with the reference designs, you have a way to reduce your development time and as well as reducing your total cost of your solution. Then I want to switch now to the second brand new release in our ecosystem that I wanted to introduce you today. So this is our IPD, our integrative passive device. Well, today when you use an STM32WL in your application, you need several components between the WL and the antenna. So that take up space, that add complexity, that also brings some performance variation across temperature. And also, each passive component will have its own tolerance, so that add an additional layer of complexity. So to simplify that, we are proposing a single device that we call IPD that integrates all these passive components here in order to simplify your wireless design. So then, you can make it smaller, you can increase the integration level, reduce the size of your PCB, reduce the thickness as well, and guarantee the performance as well. It includes, as you can see, the matching network, the balloon, the harmonic filters. All of this inside a really small package, a WLCSP package that comes in a really small footprint of 1.8 by 2.1. It is available today in sampling and will be in mass production for Q4 2022. Okay, so we have seen here our two brand new releases in our ecosystem. And now I want to switch to a different kind of ecosystem. And by that, I mean our forest. So I come from the south of France, and the risk of fire is particularly high, especially during summer. And especially with the strong wind that we call le Mistral, the fire can spread really fast. So we need to detect it as soon as possible, as fast as soon as it occurs, actually. Here, the STM32WL is at the heart of innovative solution. And Dryad's early fire detection is one of them. So Dryad is proposing this solution to prevent our forest from wildfires. How does it work? They have sensors located across the forest that can help to detect the fire and to report it to the cloud. So then we can act to stop the fire as soon as possible in this way. And this is achieved thanks to LoRaWAN protocol and a Dryad proprietary mesh network. So then the message can be relayed up to the cloud in this way. And in this application, the STM32WL is used on the sensor side. And the sensor here has been done also in an ecosystem-friendly way by Dryad, because Dryad is doing this powered by the sun, by the solar power. And so this can run as a battery-free application. And this is achieved thanks to the STM32WL low power capability. So let's have a look now. What features can enable such kind of energy harvesting solutions? First of all, Dryad got access to our flexible power implementation, the STM32WL, that allows to switch on the fly from an internal LDO to an internal DC-DC. And this DC-DC provides the best power performance because it is done with a switch mode power supply that is quite efficient. And just after, I will show you the evidence on the current consumption figures of the benefit of using this DC-DC. Then on the RF side, and more specifically on the TX, on the transmitting power output, this STM32WL has something unique, which is a dual power amplifier. There is one power amplifier optimized for the long range, high power amplifier that can go up to plus 22 dBm. And there is one low power amplifier that is optimized for the energy efficiency, and that can go down to plus 15 dBm. So for instance, in Europe, like Dryad, they can use this low power amplifier and optimize the current consumption of their application, enabling this way such energy harvesting application. Well, so let's see how this can be converted, translated into current consumption. So in reception, we can see from here the benefit of using the DC-DC. You can see here, using the DC-DC, the current consumption can go down to 4.4 milliamp in FSK modulation, and in LoRa modulation, 4.8 milliamp. And you see the difference between the DC-DC and the LDO. As you can see, we see here the benefit of and the efficiency of the DC-DC. In transmission mode, from that table, we can see the advantage of the low power amplifier and the high power amplifier. At plus 10 dBm, the current can reach 15 milliamp. And here again, this is also thanks to the DC-DC. On top of the low power capability, this allows to support worldwide. It means from the low power to the high power and from the low band to the high band. Okay, so as I promised you two inspiring use cases, let me now switch to the next one. So the next application comes from SMAXTEC. And SMAXTEC is providing here a smart agriculture solution. And more specifically, this is to monitor the health of farming cows. So actually, their solution is a capsule that integrates an STM32WL and sensors, like STMEMS, for instance. And this capsule is put in the rumen of the cow. So it can detect the disease, if any disease, as early as possible, even before there are any visible signs. So how does this work? Actually, the capsule is measuring some vital signs like the inner body temperature, the drinking behavior of the cow, the rumination and the activity of the cow. Then it reports that to the cloud, and then the breeders can be notified of any disease, of the heat and the calving behavior of the cow. So it may be surprising to see an STM32WL inside the rumen of a cow. But there are many reasons why SMACS use such kind of solution. Let's go through. So yeah, we see the STM32WL that is located in the capsule here from the slide. So first of all, why choosing this solution? It's about the modulation, the LoRa modulation that allows to have long-range capability, and in order to, especially for smart agriculture application, this is quite important to cover long distance. Then it's all about integration, because here, originally, SMACS was using two-chip solution, a discrete solution, composed by an STM32L4, a low-power microcontroller, and an external radio. And they migrate to an STM32WL that helps to reduce the size of their capsule, increasing the level of integration. Then battery life as well, thanks to the low-power architecture of the WL, they can reach up to 4 years battery life, which is quite amazing, actually. Also, Dryad got access to our whole ecosystem, and this for each stage of the project, starting from the really early stage, when it's all about learning how to use the product, learning the technology. And in this stage, we are giving access to some online trainings, to a set of application notes as well, that will describe you the technology, the product, the specificity of the product, and as well as some wiki page where you can get basic knowledge on LoRaWAN technology, for instance. On the software side, once you get familiar and you can switch to the software side to download the package, the software package that ST is providing. This is packaged in the STM32WL, and that integrates our radio stacks like LoRaWAN, and not only, actually, security services and RTOS. And then, how to prototype the application. For that, we are providing here hardware solutions with our Nucleo boards that are already certified, and the tools in order to develop the codes using our IDE, using as well our CubeMX in order to configure, to generate the initialization code, and then monitoring the application thanks to Cube Monitor to program. So as you can see, this is really like from the beginning to the really end, once you finish your code and you want to program it to simplify your life, actually. So the STM32WL is at the heart of many systems and also many modules. Here, more than 18 partners have selected the STM32WL and has integrated inside their modules. So if you're unsure how to use the STM32WL from scratch, I think you can have a look to these modules that can really simplify, first, your time to market, reducing your time to market, giving more simplicity in order to reduce your BOM, and integration, of course, because such modules are really small and can really help you to reduce the form factor of your application. Okay, so thank you very much. Thank you for listening. We have our demo booth here with some great demo. We have 2 demos. One demo showing the STM32WL in an asset tracking solution. And that is combined with a BLE, with our BLE solution, the STM32WB. And the second demonstration, it's about AI, about predictive maintenance. So that's really good to see the capability of the STM32WL to compute complex algorithm, having this in a predictive maintenance application can be suited for industrial market, for instance. Okay, thank you for listening, and welcome to our booth to discuss with our experts. Thank you.
Thank you so much, Anicet. Thank you.
Thank you. Thank you.
A quick question. So how long does the capsule stay in the cow?
It is inside the rumen, so inside the stomach. Yeah.
And how long does it stay in there? Does it not?
Well, it can stay a long time because it's the cow actually, in the rumen of the cow, it stays a lot.
Oh, wow. So this is the first edible IoT that I've seen. Has anybody else seen other edible IoT earlier? No. So whose first edible IoT project is this? Yeah, quite a few. That's mind-bending for me. Thank you so much. I really enjoyed that. Thank you.
Thank you.
A realm of new possibilities
right.
now. Thank you again, Anicet.